Hello and welcome to Programming for Beginners, a series for those people who have always wanted to learn computer programming but did not know where to start or what they needed to do before they started. My aim by the end of this series is to take you, someone who may have programmed before, or someone who's never ever touched any sort of computer code in their life, to someone who is then able to create whatever they want using computer programming. So one of the first things you'll be asking yourself is, what will I actually need? And believe it or not, there's actually not that much. A lot of things in the computing world are based around mathematics, so you will need a basic grasp on mathematics. Just basic things like multiplication, division, nothing too complicated. You're also going to need a lot of patience. A lot of the things that do go wrong in computer programming are just extremely simple things that you would have never thought of, so you do need to be patient with yourself sometimes. And the most obvious one, of course, you will need a computer. It doesn't matter what operating system it's running, it could be on Windows, Mac, or Linux, you should be fine either way. You don't need an overly powerful computer either. Just as long as it runs daily tasks perfectly fine, then you should be okay. When you work on a project, the first thing you need to decide is what programming language you're going to use. A programming language is an artificial language made to send instructions to a machine, and they're primarily used to create computer software, as you might have guessed. Examples of these include C, C#, C++, Swift, Java, Python, and many, many more. And all of these languages have their own pros and cons. For this series, we will be using Java. Reasons for this is that it's easy compared to languages such as C and C++. However, it's still conventional, unlike Python, which doesn't use curly braces or semicolons, and it's also widely used. Java is used in Android, ATMs, it was used to make Minecraft, and Java programmers are some of the highest paid. The most important thing is actually learning these programming concepts rather than the programming language itself, because at the end of the day, once you've learnt one programming language, it's very, very easy to learn another. The series will entail of approximately 25 videos, maybe more as time goes on. I'd like to also make an acknowledgement to the book Think Java, How to Think Like a Computer Scientist. A wonderful book on Java and computer science in general, and I definitely recommend it. The source code for each video's project will also be provided, so that if you run into any errors, it'll be much easier for you to spot your mistake when you're looking at my code side by side. If you're still running into issues, then instead of commenting code in the YouTube comments section, go ahead and take screenshots and then email me at queries@evh98.com, and I can guarantee you'll get a much faster and constructive response that way. Another question you might be asking yourself is, okay, once I've learned computer programming, where can I go from there? Well, there's a good few routes that you can go down. The first one is you can learn how to make 2D games for desktop, iOS, Android, and the web through my old series, How to Make a 2D Game. Like I mentioned earlier, Android is also developed in Java, so you can learn how to make native Android apps through Android App Development for Beginners by The New Boston, which is available on YouTube. Like I also said, once you've learnt one language, it's very easy to learn another. So you could go ahead and learn how to create native iOS apps using the Swift language from The New Boston's iOS Development with Swift tutorial, which is also available on YouTube. Again, you can go ahead and use C# to create desktop, iOS, Android, and console 3D games using Brachy's Unity tutorial Create a Survival Game, also available on YouTube. So there's two pieces of software that we actually need. The first is what builds and runs our code into an actual program, and the second is the software that we're going to use to actually write in our code. So the first one is called the JDK, stands for the Java Development Kit, and to get it we need to go to oracle.com, hop on over to Downloads, Java for Developers, and over here we want to click on this Java Platform JDK, go ahead and accept the license agreement, and download the respective JDK for your operating system. So I'm running 64-bit Windows. If you don't know whether your computer is x64 or x86, if it's more than 5 years old, then go ahead and download x86. If it's less than 5 years old, you're probably best off with x64. So that's what I'm going to do. Once it's finished downloading, go ahead and click on it, and go ahead and install it as if it was any other program. Once you've finished installing that, we can move on to the next step. Go ahead and visit eclipse.org, and hit this big download button over here. It'll automatically detect what operating system you're running, and it'll simply give you a big download button for it. Go ahead and click it. Once the install is finished downloading, go ahead and click on it to open it. And then within here, click on this Eclipse ID for Java developers, and go ahead and install it. Once it's done, we can go ahead and launch it. The first thing it'll ask you to do is select a default workspace, and I'm just going to leave it as it is, and hit OK. Once Eclipse opens, you'll be greeted with this welcome screen, and the first thing you want to do is tick this Always Show Welcome at Startup, because you probably don't want it annoying you each time. Go ahead and close out, and you'll be greeted with the Eclipse UI. Now don't let all of this baffle you. Most of this is actually pretty much unnecessary, so go ahead and close pretty much everything except this Package Explorer. Now it's time to create your very first project. How exciting. So in the Package Explorer, go ahead and right click, go under New, and Java Project. I'm going to call this 2, because this is video 2, Hello World. Because by convention, most people's first project just simply prints Hello World, and that's exactly what we're going to do today. Go ahead and open it up, and then under this source, and this is where all your source code will be, right click, go into New, Class, and we're just going to call this main. It can be called anything you want, but I'm just going to call it main because it's the first file that we want the program to go to, and hit finish. Now we have our main file. The first thing Java does is it looks for a main method. So we're just going to write out public static void main brackets string square brackets args and curly brackets. Now first things first, Java is case sensitive. So this S here does have to be capital and everything else has to be lowercase. Every Java program, once it starts, looks for this method, and the first line of code it runs is the first line of code in this method. And for us, that first line is going to be system.out.println speech marks hello world. Control S to save. My top tip is to periodically save as much as possible. And then hit this play button over here. And you'll see a little console pop up that says hello world. And there you go, you've successfully created your very first programming project. So in the previous video, I introduced you to something called println, which prints something on a single line. If you then wanted to print something else, but on the next line, then all you would have to do is simply copy and paste, and then run the program. And there you would have your new text on a new line. However, today I'm going to introduce you to something else, and that's just simply print on its own. Now if I did the same thing here and copied and pasted it, then as expected, that would just print on one line because this isn't println, this isn't printing on a separate line. However, there is a way for you to be able to use this method and still be able to print things on different lines. We do this through something called escape sequences. So just get rid of that line, and up here type in \n, and then once again, hello galaxy. Save and run. And there you go, you have the exact same thing that happens when we had the two println statements. Now what's actually going on here is that whilst Java is executing this, it gets to this / and says, okay, this isn't something I need to print, this is actually something that I'm being told to actually do. This is an action I need to do rather than something I need to print. So once it reads the /, it then reads the next character, which is an n, which signifies a new line. There are also other escape sequences like \t, which gives a tab indentation between the text. Escape sequences also allow for us to be able to use speech marks for printing, because as you can see here, the speech marks we're using here just tells Java, okay, we're now going to print something. We're going to print a string of text, but we can't actually print these speech marks out on their own without using an escape sequence. So it's just simply / speech marks, and once again / speech marks, and print that. And there you go, hello galaxy is in, or quotation marks as they're referred to in the US, I believe. And we can string a bunch of these together, so if we get rid of that, we can have hello on one line, and then world on the next, but indented by a tab, and world can also be in speech marks. And if we run that, we have this nicely formatted little message. Comments are an extremely important part of programming. What a comment is, it's essentially a block of text that is completely ignored by Java, and it's just for you, or the team that's working with you, to see what a piece of code actually does if it's not completely self-explanatory. So for example, if this statement was a little bit ambiguous, it isn't, but let's just suppose it is, then what I could do is, just above it, using 2 /, I could then signify that this statement tells the world hello. And if I just go ahead and run this, you can see that the code runs as if this wasn't even there. It's completely ignored by Java, and it's just for you. We can also have multi-line comments, so if I go down here and type in a / and asterisk, hit enter, Eclipse automatically fills in a new asterisk on a new line, and an asterisk and a / to end it. And I can type my comment here, in the middle line, tells the galaxy hello, and you can hit enter and write multi-line comments as such forth, and Eclipse will just automatically add in an asterisk for each new line. And here I'm just going to have a statement that says hello galaxy. Now there's a different type of multi-line comment that's formatted differently actually, and that's just simply a / and 2 asterisks, but everything else is completely the same. And here I'm just going to write tells the universe hello, and again I can have different lines if I please. I'm just going to copy and paste that. Hello universe. I'm going to run this, and these 3 statements run as if they were there with nothing else. As you can see here, these comments are completely ignored. As for these 2 differently formatted multi-line comments, they each do actually have their purpose, and you'll see that purpose as we go on through the course of this series. Today I'm going to be talking to you about the concept of variables, and a variable is simply a named location that stores a value. It's like in algebra, if I had 2x plus 5 equals 15, then although x is just given a different name, we know that the value of x is actually 5. X is just a name for this value of 5 in this scenario, and that's exactly what variables in programming are. So first, I'm going to show you the declaration of a variable, and this is essentially telling Java, okay, here is a variable, and this is what it's going to be called. And I'm just going to have an integer, and that's going to be called x. If you're not familiar with what an integer is a whole number in mathematics. But I can also declare multiple variables on one line. I can declare 2 integers, y and z, like that. And the second part to this is assignment. Assignment is when we actually, well, as you can probably guess, is when we assign a value to this variable. So I'm going to set x equal to 5. Now, first common misconception in programming, an equal sign in programming does not mean is the same as. An equal sign in programming means we're going to set whatever's on the left side equal to whatever's on the right. You cannot write 5 equals x. That's not valid. We can't set 5 to be the same as x because 5 is always going to be 5. However, we can set x to be equal to 5. Declaration and assignment can also be done on the same line. I could have an integer n and just simply set it equal to 3. Now there are other types of variables, and these are called data types. So here I introduced to you the data type of an integer, and now I'm going to introduce to you the data type string, which you will have seen before. Hello world. When we printed out hello world before, we were specifying a string. And a string, as you can guess, is just a string of characters. The final data type I'm going to introduce to you today is a boolean, and that's simply true or false. These variables can also be printed out. So if I write system.out.println, as you've seen before, I can print out x, which is 5, and then I can write plus some speech marks and a space. That just adds a space after this 5. And again, I'm going to throw in the variable s, which is this hello world. And again, I'm going to give it a space in between. And then I'm going to print out this true or false variable here. So the expected output is 5 space hello world space true. And if I run that, and indeed the output is what we expected. In the previous video, we went through the concept of variables. In this video, I'm going to go through constants, which are essentially variables, except they never change. They have a set value throughout the entire program. So I'm going to declare 2 different constants, and the first is going to be a string. It's going to be called app name, and I'm going to assign it as well. I'm going to assign it the value of test, and the second one is going to be int app version equals 1. Now something that you'll notice here is that these are in complete capital letters, and the reason for this is that a constant by convention should always be in capitals. And a second thing, which I haven't added yet, is a constant should always have this modifier here, final, before the entire declaration and assignment. This is so that you don't accidentally, throughout your programming code, change the value of this to something else. Eclipse will throw you an error saying, no, you can't change this unless you remove this final modifier. This makes sense because the app name is never going to be changed programmatically. There is not a point in time where maybe a user clicks something and that suddenly changes the entire app name. The app name will always stay the same unless I change it on launch. And again, same goes for the app version. So why do I have to make this a constant? Why can't I just refer to my app name as test throughout the entire program? Well, the reason for this is, if that time is to come and you do end up changing your name, you'd have to scour your code and find every single reference to your app's name and change that. Whereas if you made a constant and just referred to that constant each time, then all you'd have to do is just change this constant once and then you'll be good to go. And like we did with our variables, we can print out our constants as well. App name plus a space and app version, save and run, and there we have it. Now I'm going to pick up where we left off exactly in the last video with our integer division. And today I'm going to introduce to you something called floating points. And here we have 2 integers that are being divided, and when Java sees 2 integers being divided, it will give you an integer in return. Here I have 2 floating points, and that's a new data type that I'm introducing to you today. And if Java sees 2 floating points being divided by each other, then it will in fact return a floating point in return. There's 2 types of floating point, and the first is a double, and you can simply just declare this like any other variable. And the second type is just simply a float. However, with this, you have to signify that it is a float by adding a capital F on the end. The difference is doubles hold much larger values than floats. I'm going to introduce to you another data type, and that is a character. A character is essentially one part of a string. So if I had the string hello world, this H right here would be a character, this L right here would be a character, even this space right here would be a character, and this exclamation point would be a character. Every single thing in this string that is one length is a character. And a character can simply be anything, and it's surrounded by single quotes, so a character could be an @ symbol, or F, or B, or even, like I said, the exclamation mark. What we're going to get, however, is the first character in this hello world string, and the first character is this capital H. Now you'll notice I've done s.char at, which is character at, the index 0. Why is it 0 and not 1? Well, programmatically, counting is always started from 0. Whenever you count in programming, you go 0, then 1, then 2. And if I were to print out this character, then I will indeed get that capital H. One cool thing which a lot of people actually never teach, I actually only found this out very recently, is that you can apply arithmetic operators with characters. So I could grab this C and just increment it by 1. See what I did there? C++. It's another programming language. I'm not funny. This is essentially the same as C equals C plus 1. Now you might already have an idea of what we printed once I execute this. And as you can see, I get a capital I because in the alphabet, right after the capital H would be a capital I. And you can do all sorts. You can add by 5, minus by 3, and so on and so on. There's a lot of things we can actually do with strings. One of these things is called concatenation, and we've actually already looked at this very briefly. And this is the process of combining two strings using the plus operator. So if I now have a third string, S3, and just do S1 plus S2, that would essentially join these two strings together. And going back on that point of we've seen this before, where we will have seen this before is when we're printing out something and we just combine two strings, not even necessarily strings, we just combine two variables, sometimes to add in a space or something like that, and that's where you will have seen this before. So if I print out this S3, we will get the expected result of just a straight up hello world, these two strings being combined. You do have to be careful with concatenation sometimes though, because sometimes Java just automatically converts stuff that you don't want to be converted. So for example, if I had system.out.println and I have the integer 1 plus 2 plus S3, then what Java will do is instead of printing out 1, 2, hello world, it will print out 3 hello world. If you want to avoid this, you would have to make these integers into quote unquote strings. Pretend strings really, and then if you print that, that would print out just fine. The reason Java does this, however, is that it looks at this 1, and then sees the plus and looks at the 2. It then performs this straight up 1 plus 2, and just does 3, then sees this plus and adds on the string at the end. However, if I do it in the complete reverse, and I do S3 plus 1 plus 2, what Java does is, it prints out that string, and then goes, right, I need to add 1 onto this string. Then it sees this other plus and goes, right, I need to add 2 to this string, because once it adds the 1 on, this becomes a string. It's very complicated and very annoying, but this is something you have to be aware of. Strings also have some amazing internal methods, such as being able to convert everything to lowercase. So what I'm doing here is I'm setting the string S3 to the value of whatever S3 would be if everything was lowercase. And there you have that, the H and the W are now lowercase. And the same is to be expected if you use the method to uppercase. Another neat thing is the replace all method. So I can take a certain part of a string and replace all instances of it with something else. So if I want to simply replace this world part with, say, universe, you'll see that it actually doesn't work. And the reason for this is that once again, programming is case sensitive. It was looking for world with the W uppercase and everything else lowercase, and it couldn't find it, so it didn't do anything. If we then correctly write in world and universe, you can see that it's replaced it perfectly fine. And finally, there's also a substring method, so you can grab a certain part of a string and just print that. So if I just wanted from 0 to 5, then I would get just that hello part. To obtain user input, we need something called a scanner. To initialize a scanner, just simply type in scanner with a capital S, name it whatever you like, so I'm just going to call it scanner, then equals new scanner system. This sort of makes sense because we've been using system.out to print stuff out for quite a while, so now for taking input we're going to use this system.in. You'll be given some red underlining. Just go ahead and hover over and then click this import scanner, or you can hold Control, Shift and O and Eclipse will automatically import anything that needs to be imported. I'm going to briefly explain this whole import business. In Java we have files like system which are already included because they get used so frequently. Java just assumes you're going to be using system at one point, so it's just already imported for you. Then there are files like the scanner, which are not always used, so Java doesn't bother importing them for you because that would just be unnecessary. So we have to do that manually up here. Now you might think that this scanner looks like a variable, and you are kind of right, because if you do hover over here, it does say the value of local variable scanner is not used. But it's not technically a variable, and that is something I'm going to have to explain quite far into the future, so just hang on here with me for the time being. Now actually taking input using this scanner is extremely easy. I'm just going to print out a brief prompt that's going to ask what someone's name is. Then I'm going to initialize a string called name, and this name is going to be equal to whatever the scanner gets on the next line. Next line just grabs an entire line of string. If I wanted an integer, I would simply rename this to int and then have next int or whatever variable type is applicable. But for right now, we need a string. Then all I have to do is just print out nice to meet you, whatever their name is. And again, here you see concatenation being used. And then just an exclamation mark. And we can run this. What's my name? Just click over here. I'm going to put in J. And there we have it. The math class in Java has an array of useful methods that we can use. The first one being square root. So if I just initialize a double variable named x and just type in math.squareroot and put in 4, then I in fact get 2.0. The reason it's a 0.0 and not just straight up 2 is because this is a double. I can also use exponentials using math, so if I set x now equal to math.pow, which is power, and I want 2 to the power of 2, then I will get the expected 4.0. And there's nothing to say I can't combine these methods, so if I then wanted to get the square root of whatever that value was, I can do that, and then simply run, and I get the expected 2.0. Trigonometry is used in quite a lot of advanced game development, so it's very nice indeed that Java has a lot of trigonometric methods. Let's just start fresh and initialize a completely new variable of y, and have it equal to math.sine, which uses the sine function, put in 90. Now we know that sine 90 degrees is 1. However, if we print that out, then we actually get a completely different answer to that. The reason for this is that this is done in radians and not degrees. Radians are just a different method of measuring angles, rather than degrees. As you can see from this fantastic GIF, half of a circle is equal to pi radians. And so, consequently, a full circle is equal to 2 pi radians. To convert from degrees to radians, all you have to do is multiply by 2 pi, and then divide by 360. So 90 would actually be math.pi divided by 2 in terms of radians. And if I run that, then we get our expected answer of 1. However, I can also use the extremely useful math.toRadians method, put in 90, and we have a degrees to radians conversion, and then we get our expected answer of 1 again. And of course, by far the most useful method is math.round, and this just simply rounds any floating point up or down to what their respective value would be. Now you've probably heard me use the word method quite a lot throughout the course of this series. In this video I'm actually going to show you how we would go about making our own and using our own methods. What a method is, it's essentially a set of instructions. So as you can see, this println is actually just a shorthand for a load of other instructions. In the real world, you would have a method like brush teeth. Now brush teeth isn't as simple as that. Brush teeth is made up of a load of other actions. Those actions include going to the bathroom, which again could be a method made up of other actions. Then you would have picking up the toothbrush, applying the toothpaste, then actually performing your daily ritual toothbrushing of thing. Anyways, you get the point that I'm trying to make. So let's go ahead and create our first ever method. Now we're going to follow the same thing as this main method here and copy and paste this public static void. You'll soon know the significance of these 3 keywords eventually. And here we put the name of the method, and I'm just going to put greeting to world, empty brackets, and then a opening squiggly bracket, and if I hit enter, Eclipse will just finish up with a squiggly bracket there. Now one thing I do want to stress in regards to naming these methods is camel casing. Camel casing is very important and it's used by pretty much everyone when it comes to programming in Java. How this format works is your first word is all lowercase. Any words after that, their first letter has to be capitalized. So essentially the first letter of every word is capitalized except for the first word. Now in this greeting to world, I'm just going to make this a shorthand for system.out.println hello world. So instead of this, we now have our little shortcut. And to call it, I simply have to type the name in, add these brackets, and then a semicolon on the end to terminate that statement. If I run it, then I get the expected hello world response. You might be asking yourself, why is this necessary? Why do we have to do this? Well, there's two main reasons. The first is repetitiveness. There may be times where you're running a block of code consistently throughout. Wouldn't it be easier to just reference this method name 5 times rather than write out all this block of code 5 different times? Which then brings me on to my next point. It's also much easier to read. Good code is not code that necessarily runs fast, but good code is most importantly code that is readable to everyone. But if we go back to that brushing teeth analogy, it's so much more strenuous to just say, okay, first I have to tilt my back up 90 degrees and then rotate round, put my feet on the floor, get up, walk exactly 5 paces forward, turn right, walk exactly, it's so much easier to just say, I get out of bed, I walk to the bathroom, pick up my toothbrush, and then inside those statements have even smaller statements and just build it up like a pyramid. I'm also now going to show you the importance of those second type of multi-line comments. So I know I showed you these kind of multi-line comments, and I also showed you this type. This second type is always used for methods. This is always used to show what a method does, and it always goes right on top. So here I'm going to write shorthand method that prints hello world. Now, if I hover over here where I've called that method, I now get a nice little window that shows me what that comment says. I'm going to copy and paste this method and create a greeting to universe. And this is simply going to greet the entire universe, which again is fairly self-explanatory. But then I'm going to create a final method, and this is going to print hello world and universe. And this method is going to be called greeting to everyone. And here I'm going to be using that whole pyramid analogy again. This method is going to call greeting to world and greeting to universe. And then in my main method, all I have to do is simply just call greeting to everyone. And there we have it. So not only can I just greet the world when I want, and greet the universe when I want, but I can also greet everyone. So I could greet everyone once, then greet the world twice, greet the universe once, and then greet everyone again maybe thrice. One thing you might have also noticed is that none of this is in order. Surely all of these three should be before main, because everything in computer programming runs one by one by one. This is true within methods. The first thing Java looks for, it doesn't matter what else is in there, the first thing Java looks for is this main method. Once it's found it, it looks at the first statement, which is greeting to everyone. It will then find this method wherever the hell it may be, and that just happens to be down there, which is fine. It will then go down to the first line, and then see this greeting to world. It will find, again, wherever it may be, it doesn't matter. So we can actually take our custom methods that we've made here a step further and add parameters to them. Parameter is something that you pass through to a method. So for example, if you see here, in this greeting to everyone method, there are no parameters. We just have empty brackets and that's the end of the story. However, in the println method, inside the brackets, we have a singular string. That string is a parameter. This is something that the method is going to do with this piece of information. So we're going to delete these and create an altogether brand new method. And this method is just going to simply be called greeting. And we're going to pass through a string, and this string is going to be a place. You can call this whatever you like, it doesn't matter, but make it informative. So instead of having a method for each different place, we can just simply print out the name of the place that we want to greet and have everything all in one method. And then we can change this greeting to simply greeting, and we want to greet the world, so we'll pass that string through. We could even have this as a variable, and we could pass that through. And it would still work all the same. If I hit run, it works perfectly fine. And we can add comments to this method, but when you do that, you'll see that Eclipse has automatically added this @param place. So first let's just give the method description. So a method to greet a particular location. And here, right after this, we're going to write what the parameter is for. And this is going to be the place to greet. Now if we hover over our method here, you can see it then says parameters, and then in bold, place, the parameter that we have, and then it says what that parameter is for. I'm going to write out a second method now, which is going to show you how we would go about using multiple parameters. So we could have a greeting, again, string origin, string destination. So we can say hello from a certain place to another place. Now one thing you'll have noticed is that, hey, we've got two greeting methods here. Is that allowed? And yes, it is. This is called method overloading. This is when you have a method of the same name, however, they have different parameters, and so technically they're treated as different methods. The println method does it too. If you notice when I type out the println method and look at the autocomplete here, there's quite a long list of different println methods, each of them taking in different parameters, and so therefore they're counted as completely different methods. But anyways, here we're just going to print hello to the destination from our origin, exclamation mark. Now you can see we've used our destination first and then our origin second. However, when we define the method, we're going to give it the origin first and the destination first, because that just makes more sense. So here we could have a greeting from the galaxy to the entire universe. And as you can see, our parameters are just filled in. Hello, universe from galaxy. And again, we can add a comment to this method as well, and will automatically be given two parameters. In computer programming, a relational operator is something that operates a test or a relation between two entities. Let me explain this further with an example. So if I had two integers here, 5 and 6, each named a and b respectively, and I wanted to see if a was bigger than b, so essentially test the relationship between these two entities, then I would be able to use a relational operator. If I ask Java, is a bigger than b, just straight up, that's illegal. If I create a boolean, is a bigger than b, and I set this equal to a more than b, this is a larger than b returns a true or false value, which this boolean is then set to. I could also do more than or equal to, I could also do less than, and I could also do less than or equal to. I could also do is it equal to, and this is where a single equal sign is different to two equal signs. Remember in the variables video I said to you that a singular equal sign means that Java is setting a variable to something. Two equal signs means I'm testing whether or not two things are equal. However, we're just going to stick back to this more than operator. I can then print out this boolean and see if that is true, and it isn't. 5 is not larger than 6. Now of course you can do this with floating points as well, but you can also do this with strings. If I asked if Jack is equal to Alex, then that of course is going to print out false. However, if you are going to try and ask whether or not two strings are equal to each other, this isn't the best way. The best way is to use the built-in equals method. So once you have a string, just type dot equals and then put that in. And again, we have the expected output of false. So we're going to be continuing off our is a bigger than b example that we had in the previous video so that I can explain logical operators. And what a logical operator is one of three things, and that's either and, or not. Let me show you what I mean. If I cut and paste this whole Jack equals Alex business, and then here add two ampersands and paste it in, this is now asking Java, right, is a bigger than b, and does Jack equal Alex? Both of these are false, so therefore, if I save and run, I will get false. Even if I change the value of a to 7, making this true, but this false, it will still print false because both of these statements need to be true. I can, however, switch this out for two pipes, which is the key to the left of Z. Just hold down Shift and press that. Now if I run this, it turns out true, because what this means is or. Is A bigger than B? Yes, it is, true. Does Jack equal Alex? It doesn't matter because one of these conditions is already satisfied. And the final one is not, so I can just get rid of this completely and go back to the original value of 5 for A, print this out, and of course we get false. However, if I stick an exclamation point right before that, then it turns out as true. And what this exclamation point is, it just means not, and that essentially inverses whatever that is. These logical operators can also be combined, so I have a not here, and I have an or here. And if I play that, then that returns true, because not is A bigger than B is true, because A is not bigger than B, but we put this not here, so therefore A is not bigger than B, which makes this true. Or Jack equals Alex, which it doesn't, but it doesn't matter because this whole expression here is true. Now finally, in this video, I bring this whole is A bigger than B example to full circle. Now that we've covered relational operators, logical operators, we can move on to conditional statements. A conditional statement essentially just tests a condition. So, for example, I can write if, and then in brackets, A is bigger than B. I can just straight up use this variable as well, but I'm just going to show you this just for example purposes. Then I just fill in some curly braces. Now, anything inside here, any code I write here, is only executed if A is larger than B. Pretty straightforward, right? And I'm just simply going to write that. If I run it, nothing gets displayed because this condition was not met. I can also extend this and write in an else right here. Right after the closing curly brace of the if statement, I can add an else here, and then a set of curly braces. Any code that's here is only executed if this statement is not true. Again, pretty straightforward. So here I'm going to have B is bigger than A, and if I run this, then in fact that statement does run. However, there's a problem here. There's also a third condition that I'd like to test, and that's whether or not they're equal. Because if I change A now to 6, then the program would tell me that B is bigger than A, because B is not more than A. And the reason for this is that A isn't bigger than B. They might be equal, but A is not bigger than B, therefore it's just going to execute this. So, in the middle of all this, we can have an else if statement, A equal to B. The else is essentially just if none of these are true, then this is the default, because I can add as many else ifs that I want, and it won't make a difference, as long as the else is what closes everything. But for this example, we only need just the one. And here, I'm just going to write in that they are equal. And alas, if I run it, then finally I get the expected response. This whole thing can be accomplished on one line without any curly braces as well. However, people tend to use curly braces just to make their code more readable. However, if something's glaringly obvious and really doesn't need those curly braces and just pretty straightforward, then you can condense your code a little bit and just simply do this. If, and this time we're just going to grab this boolean, if this boolean is true or not, then simply just print this out. As you can see, there was no need for the curly brace here. We can just simply do that. And if I change the value of A to 7 and run this, then of course we get that initial A is bigger than B, and then we get this second A is bigger than B. If I wanted to add some else ifs and an else, it would be kind of messy. It wouldn't be too bad because everything inside these if statements is just one line long. However, if I were to have more lines, then it would start to get messy. So rule of thumb, just stick to the curly brackets. However, it's nice to know that this is possible as well. In this video, I'm going to show you the process of calling a method from within a method. It sounds quite complicated, but it's actually quite interesting once you get your head around it, and it's actually not even that difficult to understand. So here, as you can see, I've got this empty countdown method created, which counts down from a specified number, which is going to be this integer n that we're going to pass through. And essentially, what we want to do is keep printing this number as it decreases, and eventually, once we count down to 1, we want to print blast off. So let's start off with that. If n is equal to 0, we don't want to print 0. Instead, we want to print blast off. However, after we've done that, we want to continue this countdown, except on number 1 lower than the number we're currently on. Because if I've just printed out 10, then obviously I want to go down to 9, which is going to skip that, but then goes to this else, and then print out 9. Eventually, I'm going to get to 1, print out 1, and then this has to run again for me to be able to test this n equals 0, and then print blast off. So what I need to do now is call this countdown method again from within, except this time pass through n minus 1. So whatever the number is before n, which is our current number. And now if up here I just call this countdown method and start counting down from 10, then you can see that it prints out the values that we are to expect. So to demonstrate the concept of loops, I'm going to be using the countdown example from the last video, because it's pretty straightforward and gets the point across. So the first kind of loop is a while loop, and essentially how that works is you type in the keyword while, and in brackets you type in the condition. So in our case, as long as n is more than 0, so whilst this is true, keep doing this. And what we want to keep doing is we want to print out the value of n, and then each time we want to subtract n by 1. As soon as this statement becomes not true, so as soon as n is not bigger than 0, then this block of code stops running. So we can then continue on to system.out.println blast off. And this line of code won't execute until this while loop is finished. So if we entered n as 5, it would go, okay, 5 is bigger than 0, do this, 4 is still bigger than 0, do this, and so forth until the condition is not true and it gets here. So we can call this up here, and again put in 5, run that, and it runs as expected. The next kind of loop is actually extremely similar, and it's called a do-while loop, and it follows the same premise, except it executes the block of code first, then checks a condition, so it's essentially a reverse while loop. It sounds slightly complicated, but it's actually not. So if I just type in do, and then curly braces, and then copy and paste this, then afterwards put in while n is larger than 0, then I have this blast off below here. Now as you can see, if again I input n as 5, it will print out 5, subtract it by 1, check it, and then loop back, and then keep going until we get to blast off. So again, if we call that and run it, then again we get the exact same output. The final type of loop, and probably the most common, is a for loop. It's slightly complicated at first, but once you get the hang of it, it's great. So just type in the keyword for, and then in these brackets here, the first thing we need to do is create a brand new variable, and that variable is going to keep a track of the amount of loops that we're going to be doing. So by convention, it's usually I. We just name an integer I, and we just want to set this equal to whatever n is, and then a semicolon. And then the next thing is the condition. So as long as I is bigger than 0, semicolon, and then what do you want this loop to do to the variable each time it's passed through? So I want the value of I to be reduced by 1 each time. The advantage of a for loop here compared to a while loop is that if we didn't have this int n already, then in a while loop we'd have to create an entirely new variable just to keep a track of how many loops are going. Whereas in this for loop here, we have it all done here. And here, instead of having a new line of code just to change the value of the variable, we don't need that because it's already done here. So in here, all we have to do is just print out the value of I. And then down below, we can have blast off printed off. And if we play, finally, we again get the expected output. In this video, I'm finally going to go through the meaning behind this keyword void. To do this, I'm going to create a brand new method, and I'm going to type in public static, and instead of void, I'm going to type in int. And this method is going to be called calculate distance. It's going to take an integer x and an integer y. And what this calculate distance method is going to do is, it's going to take these 2 points and then give the distance between them. And it's going to return us an integer. It's going to give us an integer in return once it's calculated it. A void method is just a method that would just run without returning anything. It's a method for the purpose of just being ran. Println is an example of one of these void methods. We give it hello world, and it just simply prints as we've asked, and it doesn't give us anything back. On the other hand, the math.squareRoot method, we give it something, but it also gives us a value back. It gives us a double, it gives us the result, and we can use that as a variable. And this is exactly what this calculate distance is going to do. It's going to give us an integer. So what we can do is we can initialize an integer I, and this is going to be equal to x minus y. And then we can simply return this I. And so once we pass through these integers, it's going to perform this calculation, and it's going to return the result to us as an integer. There's a slightly quicker way to do this. We can just put this x minus y here and just return it all in one go. Now, there's a problem here. When the user inputs point x, it's going to be somewhere here on the left, whereas when user inputs point y, it's going to be here somewhere on the right. If I subtract this by this, it's going to give me a negative value. So what I can do here is I can use the math.absolute method, and this is going to give me the absolute value of whatever I give it. So if it's minus 4, then it's just going to return 4. And we can test that here by doing system.out.println and calculate distance, and we can input 6 and 10. So like I said, that would give me minus 4. However, this method is going to kindly give us the absolute value of 4. So I'm going to create another method here, and this is going to return a boolean instead of an integer. I'm just doing this just to show you that you can use absolutely any data type that you like. And here I'm just going to return whether or not the distance is bigger than 5, because this is going to give me a true or false value, this statement here, and I'm going to return that. So what I'm going to do here is I'm going to give the isDistanceBig the parameter of this method. So I'm essentially going to nest them together. So up here I'm going to type isDistanceBig and then wrap it round this calculate distance method. So what Java is essentially going to do here is it's going to go, okay, is distance big? Okay, we're going to take an integer distance. What is that integer? Oh, okay, It's this method. So let's go over to this method. Okay, what are we being given for x? We're given 6. What are we given for y? We're given 10. Run this calculation. The answer is going to return as 4. Okay, we can give that here. We now have a value for u is distance big, and that value is 4. So we can input that as the integer here. Is that bigger than 5? No, it isn't, so you're going to be false. Now, to you, we can print out false. And if I save and run, then of course I get the expected output of false. An array is an ordered arrangement, so in this case I've declared an integer array, which is essentially a list of ordered integers, all in one variable. So that's the declaration. Now for the assignment, what you actually have to do is, you have to set values equal to new integer, then decide how many you want. Now I want 6, so I'm just going to put that in. However, if you choose to do declaration and assignment all in one go, then what you can do is, you can just set this equal to a set of curly braces, and then put in all the values you want. So I'm just going to have 1, 2, 3, 4, and 5, separated by commas, and there's my integer array of 5 length with the values put in. For this array here, if I wanted to change any of these values, or in this case, set initial values, what I'd have to do is, I'd have to do values, square brackets, and then the index of which one, so the first one, 0, because counting in programming starts from 0. If I wanted to change the value of the first integer, I'd have to do that, and then set it equal to whatever I like. I could also use the arithmetic operators that I showed you in one of the early videos, and I could do other values, 0, plus plus, and so that would mean that this first value of other values would be equal to 2. I can prove that to you by printing it out, so if I just hit run, then of course we get 2. Now if I wanted to print out the entire array, then I can do that. So if I just type system.out.println, and just typed in other values just straight up, and printed that, you're not going to get the value that you expect. So instead what you have to do is you have to type arrays.toString, and then put this in. Then we can run, and then we get our list. Another way of doing this is through an enhanced for loop. So I introduced you to the for loop in a previous video, but now I'm going to do them with arrays. So if I just once again type in for, and what I can do is first I have to state the data type, which is an integer in this case. Then I have to pick a name for each one of these. So each one of these I'm going to say is a number. And then a colon. Then I have to tell which list am I getting it from. So I want to get it from here. And there we have it. This I can call whatever I like. What this essentially doing is, each time this for loop runs through this other values, each value is going to be given the temporary name of number. So I can do system.out.println and put in number. If I print that, and I get this. Because what it's doing is, it's going for. Okay, I'm going to grab an integer number from other values. And that's going to be this one. Obviously we changed it here, so that's now 2. So int number is equal to 2. I'm going to print out 2. Then it's going to go, okay, now for the next one. I'm going to get the second value from other values, and I'm going to call it int number. Int number is now equal to 2, again, and then print that out. And then so on and so on. Finally, I can grab the size of an array. If I just print out size, just type in other values dot length, not size, but length. That is what you want. And that returns an integer of the length of the array. And if I print that, then here I get size 5. 1, 2, 3, 4, 5. Perfect. Objects are probably the most important thing in Java, and they're a tricky concept to get your head around at first. An object has a collection of variables and methods. The best way to show you what an object is to just show you. So Java has a built-in object called point. So I'm going to type in point, and then point. Think of this as the data type, which we first have to import. Think of this as the data type, and think of this as the name, like we define a variable. And again, we can assign it just like we assign a variable. We put the name on the left hand, an equal sign, and then what we want to set it to on the right. Instead of just putting in a value, we do what we sort of did with the arrays, and type in new, and then points. And then empty brackets and semicolon. We can just leave it like this, however I'm going to put in some values in these empty brackets. I'm going to put in 3 and 4. This is the x and the y position. And so now what's happened is, I've created a new point, and point already has an integer x and an integer y built into it. I've now set that x to 3 and that y to 4. Not every object has those variables, point just happens to have them. So the proper way of referring to a variable in an object is an attribute. And to change the attribute of an object, there's usually built-in methods. So if I type in point and just hit dot, then I get a list of these. I can get x, I can get y, and as you can see they return doubles. But I can also set location, so I can change this right here. I'm going to set the location, and I just want to change the x. I want to change the x from 3 to 5. But I want to keep the y the same, so all I have to do is just put in point.getY. And if I want to print out the values for x and y, all I have to do is refer to them point.getX and point.getY. And if I hit play, then I get the correct values 5 and 4. So I'm going to expand from the last video in which I introduced to you the concept of objects. And in this video, we're going to create our very own object using a new class. So here, I'm just going to declare and assign a brand new object. This is going to be called time1. It's going to be of the type time. And I'm just going to type in new time. Now, of course, we have errors. If I hover over here, I have two options. I can either import and use the Java time, or I can create my own class time. I don't want to use the Java time, I want my own. So I can either click there, or I can click here, or I can right-click here under New and then Class. And here I have to type in time. The name of the class has to be the exact same as the name of the object that you've given. So I'm just going to hit Finish. Now, just like the point object had the x and y attributes, the time class is also going to have some attributes. And those are going to be hour, minute, and second. Now, the first thing you might be wondering is, why are we using private? This is the first time I've actually shown the use of the keyword private over public. The reason is because we're creating a new object and we can have multiple instances of objects, you can create more than one, we don't want to be accidentally accessing these variables, so we just pop on private just to be safe. Now, as you can see, we've got some warnings here. If I just hover over, then one of the solutions is to create a getter and a setter, and that's what I'm going to do. This is so we can safely access these variables. And you'll hopefully remember that with the point, we did have getX and setLocation. So that's essentially what these do. And I'm just going to generate these for all of them. And these methods don't really need a comment because they're extremely self-explanatory. Now, the last thing we need to finish off this object is a constructor. The constructor is essentially a method that says, hey, this object is being created. What do you want to do? So if I go back into main here, when I say new time, that's essentially just running a method called time. So in time, let's create a public time. Now you notice there's no void or int or whatever, and that's what tells Java, right, this is a constructor. It also has to be the exact same name as your class. Now constructors can also have parameters, so when I define a time, I want to be able to give it an hour, give it a minute, give it a second. So I'm going to just type in here int hour, int minute, and int second. Now, as soon as I do that, main gives me an error. I'm being thrown an error because I haven't given this an hour, minute, and second. So that's what I'm going to do. I'm going to define 9:15, so 9:45, quarter to 10 on the dot. There we go. Now if I hop back in, I need to actually do something with these parameters. I can't just run an empty constructor. And there's two things I can do here. The first, I can do this.hour equals hour, and do that for all of these. And what this essentially does is get the hour that's of this class and set it to the hour that we've been given here. Or I can just simply write set hour, and use the internal hour method here, because that just essentially does the same thing, as you can see there. It's up to you really which one you want to do. So now I have my constructor. Now let's say I'm in a scenario where I want to define a time object, but I don't know what time I want to give it yet. I just want to give it a default value and then maybe come back to it later to give it some values. What I can do is, overloading is not only just a thing with methods, but I can also overload constructors. So I can define a second constructor here, except with empty parameters. And here, I'm just going to set hour to 0, and minute and second also to 0. I'm just going to set midnight as the default time here. So if I then hop back into main, and we're pretty much done with the time class now, if I hop into here, I want to create a second time instance. And here, I'm not going to define any parameters, and that's okay. What this is then going to do is going to go, okay, this one is just going to be equal to midnight. And again, like with the points, I can use the set methods that we created to change the attributes. So let's say time1.setHour, I misread the time zone. I'm actually meant to be an hour ahead on this time. So I can just get the hour, and then add +1, and that would do the job. That would make it 11:15, 10:45. Let's now say for time 2, I now have an idea of the minute I want to give it, so I can just simply set minute and give it that absolute value of 30. Now I've created some very elaborate println statements, and these are essentially going to give me the 2 times in a nice little format. So if I just hit run here, then I get exactly as I wanted. I have my 11:15 here, and I have my midnight right here. So to show you the concept of inheritance, I've actually already created an object called vehicle, and there's a few things you might actually notice here, which I'm just going to go through now. So the first thing is that, okay, you've got some attributes which have the final keyword attached to them. That must mean that they're constants, right? If that's the case, why aren't these capitals? Well, just because it says final doesn't mean they're constants. Because you can have multiple instances of an object, there's never ever one model. Well, there might be, but I could have about 50 different vehicles, which would mean there's about 50 different models in my program. So this isn't actually a constant. Another reason why it isn't a constant is because I haven't defined the variable on the same line. I'm going to define it later once the actual vehicle has been created. But why have I give it a final? Well, that's because after I do create it, I don't want it being changed. If I have a vehicle, why would the model number suddenly change? Why would its manufacturing year suddenly change? You know, things like that just don't change. The only one which maybe the final attribute isn't necessary for is max speed. And so as a result, there aren't any set methods for these attributes. And so as a result, I've had to go with the good old this dot and then equals method rather than just put set here. Okay, now we've got that out of the way. What I want to accomplish with this program is, okay, so I've got this vehicle object, but I feel like half of my vehicles are going to be cars, and all cars are going to have the same size. So like I could have a motorcycle with size 1, cars would be size 2, and trucks would be size 3, anything else would be size 4. So I feel like about half of my vehicles in this program are going to be cars, which means they're all going to have size 2, and that creates a bit of redundancy. And redundancy is not a good thing. So what I'm going to do here is I'm going to create a car object, and that's going to be the child of vehicle. So it's going to inherit a lot of these things, except size. It's just going to have a default size of 2. So let's go ahead and do that just to show you what I'm actually talking about. So I'm going to right click here and create a new class. I'm going to call this car. First things first, right at the top here, I'm going to write extends vehicle. That essentially says, okay, vehicle is my parent class. And I get a warning here that I need to add a constructor. So let's go ahead and do that. Now in this automatically generated constructor, the first thing you'll notice is that I have this super statement being called here. What's that? Super essentially calls the constructor of vehicle. Rather than go through all of vehicles attributes and, you know, do that here, it just calls vehicles constructor. It's just easier that way. However, like I said, for car we don't actually need to define a size, so we can take that off and we can tell vehicle that all of our car sizes are going to be 2. We don't need to define the attributes, and we don't even need the methods. It just inherits all of it. So only in a couple lines of code have we created this car, which automatically sets a default size of 2. Let's hop back into the main class and go ahead and declare and assign these objects. So I'm going to first define a generic vehicle. It's going to be a vehicle called generic. And this is going to be a new vehicle. And it's going to be given the model of generic 3000. It was manufactured in 2017. It has a size of 1. It's a motorcycle. And a top speed of 24.8 miles per hour. Now I want a car. So let's just call this car. And this is going to be a new car. And the model of this car is going to be the Mercedes Benz Super. As you can tell, I know nothing about cars. And this was manufactured in 2017 and has a max speed of over 9,000. As you can see here, I didn't need to put in that size. I just went straight from year to the top speed. Now I've created these very elaborate println statements, and as you can see here, car has all the get methods that vehicle does, even though we didn't actually define them. It even has get size, even though we didn't have to give it, because get size by default is just 2. And if I go ahead and run this, I can see the generic 3000 is 1 unit big, because I did define that, and it has a 24.8 miles per hour top speed. And the Mercedes-Benz Super 2017, even though I didn't define it, it is 2 units big, because by default all cars are 2 units big. Now before I close off, you may have noticed that instead of the attributes being private, they're actually protected. Private and protected are pretty much the same thing. The difference is that with protected, child classes are able to access and use these attributes.